In section 5.5, we are going to be continuing to factor polynomials. Remember, we already learned how to factor polynomials by factoring out the greatest common factor. We learned how to factor them by grouping, and we looked at some special products. Now we're going to be looking at a different type of factoring, which is called factoring trinomials, and we are going to be seeing trinomials when there's two situations that happen. The first number in the trinomial will either be 1 or it will not be equal to 1. So in example 1, we're going to be factoring trinomials. Trinomials are always in this format. So the format, the original way that it's going to look is ax squared plus bx plus c. But in all of these examples below, in a through f, all of the first numbers you see are equal to 1, meaning that this number here is actually 1. So if you look at each one of these examples, if you see how they just start out with x squared, there's no number in front of the x squared, that means that there is an invisible 1 there. When this happens, it's actually it's easier to factor a trinomial. When we get down to this section, it's going to become a little bit more difficult. But when we are factoring trinomials, the first thing you should always do is look to see, is there a greatest common factor I can take out of all three terms? Well, I'm looking at the first one, and it's 1x squared plus 3x minus 4. There are no factors that go into all three of those numbers besides 1, and factoring out a 1 is not going to be helpful in this case. Also, thinking back to the next type of problem we looked at, which was factoring by grouping, there's not 4 terms, so I can't split this in half and factor one side and the other because there's only 3 terms. That only works for if you have 4 terms in order to do that type of method. So the next method we have is a factoring trinomials method. And what happens with this is when you have a trinomial, you're always going to have your answer be a binomial times another binomial, kind of like this. So it's either going to be x plus a number times x plus a number, or x plus a number times x minus a number, or x minus a number times x minus another number. And here's how it works. What we do here, we have an a number, a b number, and a c number. When we're trying to factor trinomials, we're trying to see what multiplies to be ac, but also adds to be b. So what multiplies to be AC, well, A is actually equal to 1 in all of these questions. So basically we only have to look at this number here. So we have to figure out what multiplies to be -4 and at the same time adds to be 3. So what we would do is list the factors of -4. I'd like to kind of just list them as the positive factors of just +4. The positive factors of 4 are 1 and 4 and 2 and 2. We need, in order to get this factored, we need to find which pair of factors can multiply to be -4 and also at the same time those two numbers add to be 3. So this just takes a little bit of guess and check. So if we look at 1 and 4, to get -4 as a product, 1 could be negative, like -1 and +4. Or the opposite, 1 can be positive and 4 can be negative, like 1 times -4. Looking at the 2's, this could be -2 and +2. Those multiply to be -4, and then the opposite would still be -2 and +2. Now, you have to pick the correct factors in order for this to work. You need it to multiply to be -4, but at the same time add to be 3. To multiply to be -4, you need 1 positive and 1 negative, and the negative number that you're going to need is a -1, since -1 plus 4 equals 3. So because -1 times 4 equals -4 and -1 plus 4 equals 3, that means that -1 and 4 are the 2 factors you're going to put into the answer. How we do this is we put it into these binomials here as x minus 1 and then x plus 4. In any order is fine. If you put the x plus 4 first and the x minus 1 second, it still will work. But what you are doing is finding the factors that would multiply to be this trinomial. So if we think back to 5.3 when we were multiplying, if we were multiplying x minus 1 times x plus 4 through FOILing, we would multiply x times x and get x squared, x times 4 to get 4x, negative 1 times x to get negative x, and negative 1 times 4 to get negative 4. We would then simplify this problem to get x squared plus 3x minus 4, and that would be our final answer. Now what we're doing is the opposite of that. We are now given this type of problem. We're given the polynomial in standard form, and now we are trying to take this and make it look like that. We're trying to take it and factor it to what we basically did in section 5.3. So it's just going backwards. So instead of distributing, we're now factoring, which is kind of like dividing it out almost. Looking down at letter B, I'm just going to clear out some of this work here so that I have more space. For letter B, we're doing the same exact thing again. The process is still going to be the same. All of the numbers here in front of x are 1, but usually what you're trying to do is find out what number multiplies to be this times this, and that's equal to negative 8, since 1 times negative 8 is 8, and at the same time adds to be b. Well, the b number is negative 2. So what I like to do, even though the 8 is negative, is I like to list all of the factors of just positive 8. The factors of 8 are 1 and 8 and 2 and 4. I need to be able to add these two numbers to be negative 2. So if I'm looking at the 1 and 8, like I know 1 has to be positive and 1 has to be negative. So you can almost use subtraction, like 1 minus 8 is negative 7 and 8 minus 1 is positive 7. Those two factors are too far away from each other to ever be able to add to be negative 2. So I know that 1 and 8 are not going to be the factors I'm going to choose because I need to get a negative 2 from my answer. So then you go to the next step, 2 and 4. Well, 2 is 2 away from 4, so I know I'll be able to add to get this negative 2. Let's see if it's a negative 2 and a positive 4. Well, negative 2 times 4 does equal negative 8, but negative 2 plus 4 equals positive 2. And I need it to equal a negative 2. So it's not going to be a negative 2. It's actually going to be a negative 4. So the two factors we're going to use are 2 and negative 4. What I do then is I set this up as x plus 2 times x minus 4. And then that is your factored form. That is going to be, and it'll end up being a trinomial if you were to multiply it out like we did here. X times x is x squared, x times negative 4x is negative 4x, 2 times x is 2x, and 2 times negative 4 is negative 8. The two middle terms are always going to be able to be combined together, and when I do combine the negative 4x with the positive 2x, we get the negative 2x there. All right, looking at letter C. Letter C, we are trying to multiply the numbers for 1 and 6. 1 and 6 is equal to 6. So we have to figure out what factors multiply to be 6, but at the same time add to be this number here. So the factors of 6 are 1 and 6 and 2 and 3. So when I'm trying to add to be a number and multiply to be another number, we just have to make sure we understand the types of numbers that we're multiplying to get. What I mean by that is this number here is a positive 6. The only way you can ever multiply two numbers and get a positive is if they are both positive, since a positive times a positive is a positive number, or if they're both negative, since a negative times a negative is a positive number. Since we need to take two numbers to get a positive and multiply them to get a positive, and at the same time add them to get a negative, we have to be thinking that it wouldn't make sense to have two positive numbers. Like if you chose the factors, let's say 1 and 6. If you use positive 1 and positive 6, 1 plus 6 is 7. It would never be a negative 5. So then you should start to think, okay, I would have to actually multiply by negatives then. So when I go to set this up, you're actually going to have two negative numbers, since a negative times a negative is a positive, and a negative plus a negative is a negative. So now let's think about these numbers being negative. So these would both be negative, and these would both be negative. Negative 1 plus negative 6 is a positive, negative 1 plus a negative 6 is a negative 7, and that won't work. Even though negative 1 times negative 6 is a positive 6, this would not work because we need them to add to be negative 5. Negative 2 plus negative 3 does equal that negative 5 that we need it to be. So the factored form for this trinomial would be x minus 2 times x minus 3. What I want you to do, please, is pause the video and try D, E, and F. All right, looking at letter D, E, and F, we are still doing the same type of thing. We're trying to factor these. I know that the answers are going to look something like this, and it's either going to be x plus a number times x plus a number, or x minus a number times x minus a number, or just one will be positive, one will be negative. The way to really tell is sometimes a little bit confusing. I know here from doing this many, many times that when this number ends up being a negative like it is, the only way to get a negative through multiplication is by having one positive number and one negative number. So I can already set it up like that. And then I already realized that I need to pick the factors that add to be negative 2, but at the same time multiply to be the negative 24. So when I'm listing the factors, I know some of them aren't going to be helpful. Like 1 times 24 isn't helpful because you can never get a negative 2 by adding or subtracting these from each other. But I'm just going to list all of them just so you can see the process and see where I'm getting this from. But hopefully you're at the point in your math career that you can kind of cross numbers out that wouldn't make sense. Like if you're going to multiply these two numbers together, you're going to get a 24 no matter what you do. Like 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24. That's the way factors work. You multiply the factors and they equal the number that you were just factoring. So what you should start to do is look for, okay, which numbers are this many apart then? Because I need to have one of them positive and one of them negative. And in order to find which pair that would be or which pairs that wouldn't be, just look and see how far they are from each other. Like negative 1 plus 24 is 23, and positive 1 plus negative 24 is a negative 23. So that's not going to work. They're too far away. The 2 and 12, if you subtract them, you're either going to get negative 10 or 10. If you subtract 3 and 8 in each way, you're going to either get 5 or negative 5. That's not going to work. It's got to be the 4 and the 6 because those are 2 away from each other. So when I subtract these two numbers, I will either get 2 or negative 2. Now, I need these two numbers to become a negative 2. So in order for them to become a negative 2, the bigger number has to be negative, which means like the 6 needs to be negative and the 4 needs to be positive. Because if we had the opposite, then it wouldn't become a negative 2. Since 4 plus negative 6 equals that negative 2 there, that's what we're looking because that's what's here. Then you have to make sure that you're using a positive 4 and a negative 6. If you mixed it up, then your middle term will not be what it should be. All right, looking at the next factor, we're looking for what multiplies to be 96 and then adds to be negative 20. So with this type of problem, we know that we need to multiply to be a positive, but at the same time, it needs to add to be a negative 20. That means that both of these numbers are going to be negative. So when you're going through these factors, and like even me, like I don't know all of the factors of 96 off the top of my head, so let me show you how you would do it. 1 and 96, I already know is not going to be helpful, but I'm just going to write it anyway. And then to get the factors going down the line, you just try all the different division problems. 96 divided by 2 is 48. 96 divided by 3 is 32. 96 divided by 4 is 24. I know that 5 is not going to work. 96 divided by 6. 96 divided by 6 is 6 and 16. And the rule of thumb is you keep going until you complete all the division between these two numbers. So 96 and 7 is not going to work. 96 and 8 does work. 8 times 12 is 96. 96 and 9 is not going to work. 96 and 10 is not going to work. 96 divided by 11 is not going to work. So those would be all the factors of 96. Now, because I'm multiplying to be a positive, but at the same time adding to be a negative, I know that both of these numbers here are going to be negative. So when I'm looking at the factors that add to be negative 20, I know that all of them will end up being negative. So I'm just going to choose the ones that when you add these together, they would equal negative 20. Well, negative 1 minus 96, that doesn't equal negative 20. That equals negative 97. So it can't be those. It's not these, not these. Negative 4 minus 24 more is negative 28. We're getting close, but not so much. Negative 6 minus 16 is not it. It's going to be this one. Negative 8 minus 12. Negative 8 minus 12 is negative 20, which means that these are my lucky factors, negative 8 and negative 12. They multiply to be a positive 96, but at the same time, they add to be negative 20. Okay, and the last one. This is the easiest type of problem because everything is positive, and when everything's positive, it just seems a little bit better. So for these positive numbers here, I know that the only way to get a positive product and a positive sum is by both numbers being positive. So when I go to find the factors of 9, which I'll just erase this a little bit, when I go to find the factors of 9, all I need to do is think of the positive factors of 9, which are just nice and easy, 1 times 9 and 3 times 3. Well, I'm going to be adding these positive numbers together, and I want to add to be 6, so the lucky set of factors would be 3 and 3. Which this is a special product. X plus 3 times x plus 3 is the same exact thing multiplied by itself twice. So you can either write it like that, or you can write it like this. X plus 3 to the second power, which is the same exact thing, just actually written a little bit easier because you don't have to write the x plus 3 twice. Okay, so that's factoring trinomials. We are going to stop the lesson here and we're going to practice.